Right. The rate of change of the constant 0 is 0, and the rate of change of v1 is a1, the rate of change of v2 is a2, and this is the constraint or the equation that relates the two velocities. And finally we have a2 is equal to minus 2a1, and this matches with our guess. So this now I think that you will be confident of handling any constraint equation in pulley problems. However, I would urge you to first guess and then also verify by a formal calculation. But these method will be definitely useful in problems where we'll get to two-dimensional problems in the next few lessons, and the constraint equation there will be not so easy to guess. However, we'll find it quite easy to apply our formal methods. So let us quickly go through what are the steps of the formal method. You have a coordinate system which is inertial, and I highlight the second step, which is that the observer marks position. So this is the starting step, and I highlight this because it's very easy to go from the position to the velocities. You just need to take a rate of change, and it's very easy to go from the velocities to accelerations. You take one more rate of change. In other words, the geometry has to be captured with the help of marking positions. And once this simple step is over, it's an easy matter to get the constraint equation for the velocities and the accelerations. And the constraint equation of the problem can be expressed easily with the help of position position measurements, which requires your coordinate system. So I have summarized the various steps, and what we will do now in the next few lessons is start worrying about 2D problems. You might have noticed that all the problems we have done, the motion is in a single direction, that's 1D. So we will need a little bit of vectors as we proceed to do 2D problems, and I'll just cover it as I solve some 2D problems for you.